Alright, we're supposed to evaluate this limit as x approaches -1 of cosine of pi over x. I don't see any reason why we can't just use direct substitution for this. So that's going to be equal to cosine of pi times -1, which is going to be cosine of negative pi. That's on the negative x-axis. It's a unit circle. That means that the x value is going to be -1. So just a quick picture. That's over here. It's -1, 0. R value is 1. So, sorry, my handwriting's so horrible. It's a new app, and the writing makes my writing worse than normal. So that means this is going to be -1, which is answer D. This problem's asking for the two-sided limit because it says, what does y approach as x approaches 3? So if you look here at the domain, if you're approaching 3 from the left, you're going to use this function. If you're approaching 3 from the right, you're going to use this function. So let's evaluate both of those functions at 3 using direct substitution and see if it works. So once again, we're going to have the limit of natural log of 3x as x approaches 3 from the left. We're going to evaluate that, and we're going to also evaluate the limit of x natural log of 3 as x approaches 3 from the right. For both of these, we can use direct substitution. So if you substitute a 3 from this right in there to x, we're going to have natural log of 3 times 3, which is natural log of 9. This bottom one, if we were to substitute 3 in for the x, we would get 3 times natural log of 3. It's in a different form than this previous answer. Is this the same as this? Well, if we take this 3, the coefficient, we can make it an exponent using the power property. 3 cubed is 27. So to sum up, the left-sided limit is approaching natural log of 9. The right-sided limit is approaching natural log of 27. Those are not the same thing. Therefore, the limit does not exist. It's non-existent. This next problem is supposed to evaluate this limit as x approaches 1. We can once again use direct substitution. So we get natural log of 1 over 3 times 1. The bottom is obviously 3. The top, if you remember from pre-calculus, is obviously 0, and that makes this 0, which is answer A. Let me explain why natural log of 1 is 0. Let's say that we just had natural log of 1 equal to some number x. We didn't know what that number was. Well, natural log of 1 is the same as saying log base e of 1 equals x. That's exponential form. This is logarithmic form. If we write that in exponential form over yonder, that would be e to the x equals 1. Well, any number to the 0 power is 1, so here x has to be 0. So for this problem, I just did the first step here. I can't use direct substitution because 0 squared is 0. You're dividing by 0, it's undefined. I took the GCF of the numerator, which was a sine. I wrote it in front. So if I divide this by sine, I'm left with cosine. If I divide sine by sine, I'm left with 1. Still can't use direct substitution. But I do recognize some things here that get me pretty excited. I got a sine of x on the numerator. If I had that over x, I could evaluate this limit as x approaches 0. I have a cosine of x minus 1. If I had that over x, I could evaluate the limit as x approaches 0. So I can rewrite this so it's the limit as x approaches 0. For limits, you are allowed to take the coefficient and bring it out in front. So I'm going to do that. I'm going to change the way this looks to be sine of x over x times cosine of x minus 1 over x. So I took this x squared and broke it into x and x. X times x is x squared, so that's fine to do that. So I got this 4 I'm bringing down, times, well, what does sine of x over x approach as x approaches 0? Well, that approaches 1. That's from our notes. What does cosine of x minus 1 over x approach as x approaches 0? Well, that approaches 0. That's also in our notes. 4 times 1 times 0, it's 0. That is answer D. 0. For this fifth problem, if we evaluate with direct substitution, it's going to be a minus a, which is going to be 0. Can't divide by 0, it's undefined. This factors. It's a perfect square trinomial. This factors into an x minus a and an x minus a. I wrote plus a. It's false. X minus a and x minus a. We can cancel then an x minus a from the top and the bottom. So now we have the limit as x approaches a of x minus a. Once again, that's from this because I wrote it incorrectly. Now we can use substitution. End up with a minus a, which is 0. So this is answer C. So this problem is a piecewise function, and it wants to know which of the following is true. If I just glance at these real quick, x is approaching 0 from the right, from the left, and the two-sided limit. So to approach from the right, which this is saying x is bigger than 0, so that's from the right, I got to use this function. So I wrote that here. In our notes we learned that sine of x over x as x approaches 0, that limit was always going to be 1. And then approaching it from the left, it's going to be cosine as the function, because here this says x is less than 0, so we're going to use this function, cosine of x. Well, what is cosine of 0? That is on the positive x-axis. That's 1. Just a quick picture of that in case you forget why that's 1. In case you're a chump. X and y-axis. 0 degrees is over here. X is 1, y is 0. R is always 1 if you're using a unit circle. Cosine is x over r. 1 over 1 is 1. So which answer is correct? Well, from the right it's 1. True. From the left is 1. True. The two-sided limit is 1. Since 1 equals 1, that makes that true. So that means 1, 2, and 3 are all true. So E is the correct answer. At first glance, my first instinct for this problem was wrong. It's just say this doesn't exist. I can't factor the top. Can't really factor the bottom. Nothing here good seems to be happening. But then I look a little closer, and I notice that the numerator has a cosine of x. The denominator has an x. So maybe that special rule with cosine of x minus 1 over x is in here someplace, but we just can't see it. Let's rewrite this as the limit as x approaches 0. Let's break these terms apart a little bit. So I'm going to take the first term, 3x squared, put it over the denominator, plus I'm going to take the next two terms, plus cosine of x minus 5, write it over the denominator. I think that you'll agree this is the same function. If I add these together, the bottoms stay the same, and I add the tops together, there's no like terms, that would end up being this. This is becoming super helpful. So if I continue to simplify this, 3x squared over 2x simplifies 3 halves x. We can find that limit easily. Plus, for this next fraction, if I factor 5 out of the top, I'm left with cosine of x minus 1. If I factor 2 out of the bottom, I'm left with x. Now, how do we evaluate this? This is actually pretty cool, I think, being a nerd. If you put 0 in for this, this is going to approach 0. 3/2 of 0 is 0. This over here, this, well, we got this plus sign, so we got a plus sign. 5/2 is going to be 5/2. There's no variable in that. And it's going to be times cosine of x minus 1 divided by x. That is approaching 0. So we end up with 0 plus 5/2 times 0, which is going to be 0 plus 0, which is 0. That is answer A. Okay, for this function, it's piecewise again. We could be using natural log of x, or we could be using x squared natural log of 2. We're supposed to evaluate the two-sided limit, and the best way to do that is to evaluate both sides of the limit and compare them. Well, to approach 2 from the left means we have to look at the domain that approaches 2 from the left. That's to the left of 2, which is here. So we're going to use natural log of x. That's why we chose that function here. To approach 2 from the right means that it's bigger than 2. That's this domain. We're going to use this function right here. Once you've established that, this problem is pretty simple because you can use direct substitution. So this first function is going to be natural log of 2. The second function, if you put 2 in for x, you're going to get 2 squared times natural log of 2, which is 4 natural log of 2. Are those answers the same? I mean, obviously they're not the same, but let's make it even more obvious. If I use the power property, I can put the 4 as an exponent for the 2. I get natural log of 2 to the 4th. 2 to the 4th is 2 times 2, which is 4, times 2, which is 8, which is 2 is 16. Now it's incredibly obvious. Natural log of 2 is not natural log of 16. Non-existent.